Welcome to qnawire.
We have a thin disk here, and we're asked to find the angular momentum about this point A. And we figured out these directions of these angular velocities by using the right-hand rule. And here, I wrote the radius out in terms of feet, and I also figured out what the mass was by taking the weight of the disk and dividing it by the acceleration due to gravity. So to start this problem, I'm going to write out the equations to find the different moments of inertia in the x, y, and z direction. So for the moment of inertia in the x direction, we can write this as 1 over 4 times the mass of the disk and times the radius of the disk squared. For the moment of inertia in the y direction, this is going to be 1/2 times the mass of the disk, then times the radius of the disk squared. And then for the z component, this is just going to be equal to the x component. Now for the angular velocities, so for the x direction, just by looking at the free body diagram, and since we used the right-hand rule here to figure out the directions of the different angular velocities, we see that omega 2 is in the x direction and omega 1 is in the y direction. So we can say that the x component of the angular velocity is equal to omega 2, and the angular velocity in the y direction is equal to omega 1. And there's no angular velocity in the z direction, so we can say that this is 0. So now for the components of the angular momentum, we'll start with the x component. This is equal to the moment of inertia in the x direction times the angular velocity in the x direction. And we can also write this in terms of their given expressions. And then we can do the same thing for the y direction. And then we do the same thing for the z component. And actually, so we know that this angular velocity is 0. So this z component is just going to be 0. So there's going to be no z component. So now we can write out the equation for the angular momentum about the point A. So this is equal to the x component I plus the y component j plus the z component k. So we're going to start plugging in the known values. So h of a is equal. So h of x, we can write that as 1 over 4 times 0.18 times 8 over 12 squared times 8i plus 2 times 16j. And this is going to be, so this part here put this in parentheses. So put this in its own parentheses. And then simplifying this down to their own components, we can get the I component, which is equal to 0.17. And then we can also get the J component, which is equal to 0.66. And this is our final angular momentum.